Development of the MagPod has been quite the journey. Though seeming deceptively simple, it took quite a while to get it to where it is now. As many of you know, we, here at Batch, learn as we go, and our knowledge tends to lean practical rather than academic. In other words, we learn from trying things, which usually ends up being the hard way. Which is partly why getting the MagPod to stick reliably on a wall was more challenging than expected. Our original instruction was to place all the magnets in the base uniformly with the North Pole facing up. While this did reduce complexity and potential confusion for those new to these types of builds, as many of you have pointed out, this arrangement was likely not the optimal for magnetic strength. Thanks to all who gave us pointers and suggestions of things to try. We got a lot of comments about using a Halbach array arrangement with the base magnets. Since a true Halbach array requires a series of four-sided magnets, which are arranged pointing in 4 different directions, we won't be able to do that with these flat disk magnets, which are effectively and functionally only 2-sided. But we wanted to see if alternating the direction of the polarity made a significant difference. Here, we use a pattern that alternates direction from the center out. Did it work? Here is our unscientific test, using a 2.5 pound, or 1,133 gram, weight. First, we try a pod base with the original uniform magnet arrangement. Then, we try the revised arrangement that has the center and outer magnet's north pole facing downward. It's able to pick up the weight, while the original arrangement cannot. Then, we tried a checkerboard pattern. This provided a significant increase in magnetic strength, even over the concentric arrangement. For comparison, here's the concentric arrangement again, picking up the same weight. Where the concentric arrangement dropped the weight after an increase in g-forces is applied, the checkerboard arrangement held on much more securely. We also got a number of suggestions to incorporate higher friction elements on the base of the pod to help prevent it from sliding down when attached vertically on a wall. We tried 2 different methods. The first utilized a revised design that included an integrated foot pad. Then, using Bamboo's AMS-compatible TPU, we output that object as a multi-material print and set that pad to print in the TPU, while the rest of the print was still output in the harder PLA+. Here we chose a gray TPU that matched the PLA+ it was used with. The Bamboo and AMS seemed to have no problem switching between the 2 materials, but it took nearly 3 hours to print. We did try printing the foot, flat, but we knew that print orientation was not going to be optimal for strength. It also ended up compromising the shape integrity of the pivot shaft. This would affect how freely and precisely the foot would pivot on the hinge screws. The second method was more traditional, using a thin sheet of self-adhesive silicone, manually cut to shape and size. These were affixed to a matching recess, added to the design of the model. Then it was time to see if either of the 2 new methods were better than what we already had, with another unscientific test. For this, we used a common build plate, which has a surface many in our audience are familiar with. The current all-PLA podfoot performed predictably, exhibiting very little friction and unable to laterally move the build plate. The multi-material TPU and PLA plus print also exhibited very little friction on the build plate. In fact, the AMS TPU printed with a fairly slick and hard surface, which was similar to what a bead of common hot glue feels like when it has cooled and dried. The silicone pad was the clear winner here, and easily gripped the build plate, allowing us to easily move it side to side. So, now for a performance test with the design revisions. You may remember that we previously tested the MagPod to hold 230 grams. Now we're loading up the pod with 500 grams. More than double the original weight capacity seems to be no problem. It resists dislodging and gravity, even when pressure is applied to the top of the pod. We've also made some updates to the model files intended to improve printability and functionality. One small tweak to the main body was made. 4 facets adjacent to the accessory bays were angled slightly steeper to reduce deformation during printing. 2 new versions of the main body are now included. One has slightly deeper magnet cavities in the base, to accommodate magnets that happen to be thicker than 3 millimeters. The other is a version of the main body that is 10 millimeters deeper than the original. All other parts, including the lid, should still fit. That's a wrap for this update. We tried to get this out as quickly as possible, especially for those who are building their own MagPods. We've updated the file package in the store, and we've reached out to those who had downloaded it prior. Thanks to all of you for your interest, suggestions, and support. As always, let us know your thoughts, questions, or concerns. Till next time.